Hi, we're up in Westfield, New York. This is where I was born and raised. We're at my parents' place, and I wanted to use Westfield as a backdrop to talk about some structures, bridges, things like that. We'll also have some local help here to go over these things. And we've got Todd Swanson, local architect, well, civil engineer and golf extraordinaire and everything else, right?
That's right.
Okay, sounds great. Okay, so Todd, I was driving down the street and I happened to see a pavilion being constructed. And I looked and I thought, hey, this is a great, you can't get a better opportunity to talk about trusses and things like that, because I've always looked at a house and wondered, why doesn't the roof push the walls out? You know, you would think the roof load would tend to push the walls out. So how is it that that doesn't work? Or how's it?
Looking at this structure overall, I believe it's probably a simple pavilion, but you have a series of columns on each side. At the top of the columns is a beam, and then set on the beam, spanning the structure, is a manufactured truss. The bottom chord of that truss would effectively be providing your lateral support side to side, so that you would not be pushing, the walls would not push out, and the lattice members of the truss itself is transferring any loading on the rafters back down through to the columns either side of the structure. And this is a similar structure you would see in any kind of housing project. And the difference might be that you have stick-built or 2x4 framing, all going back up to a header beam or header plate that is supporting the truss section for the roof.
Okay, sounds great. Okay, so Todd, this is my dad's barn, and this is built around 1850, and apparently nobody knew about trusses back then. So how did they, and again, it's 150, this is about 150 years old, so they did a good job with it. Right. So how is this still holding up?
Okay, this structure is basically a post and beam construction. Primarily the construction used back century and a half ago, 2 centuries ago. And it involves a series of bents where you have columns coming up to lateral beams going across. The bents in themselves are creating separate spaces within the barn through the longitudinal length of the barn. And then there's a beam section, a tie beam across from the end bent all the way through the barn that supports the rafters. You can see in this photo the tie beams running across the midpoint of the rafters. You can also see a section of the end bent with diagonal bracings to the column, to the structural beam going across. At the base of this photo, it's actually showing one of the beams that cross the lateral section of the barn, and it would be taking the loads, and it also acts as a tie holding the walls in place.
All right.
All right, this is another view of the barn, again looking at the cross beam, also showing a column coming down from the beam carrying the rafters. Again, this is a section of the interior bent. You can see a column at the exterior wall. You can also see the rafters with your horizontal planking. At the exterior wall, you can see sections of the siding that are in a vertical plane that would be resting on the upper beam and any girts running down horizontally, supporting the siding.
Okay. Okay, so now this is a picture of the inside of St. Dominic's Catholic Church. That was built around 1915. So now we're seeing trusses. So how's this working?
Okay, these are trusses back through the structure of the church. It's somewhat of a modified scissor truss, and effectively you're taking the roof loading, transferring it through the truss down into the walls. Between the trusses there would be a series of purlins that would support the roof decking and the roof itself. Where you see the trusses going back into the wall structure, there will be a series of pilasters on the exterior of the building that would provide the lateral support for the walls themselves, and they would pick up the loading off the trusses.
Okay. And then we've got also the Methodist Church across the street. Let's take a look.
Oh yeah, those would be providing the lateral support.
Oh,
You'd be
okay.
surprised.
All right. All right, so now we're inside the Methodist Church. I don't know when it was built, but probably same time frame. But here, this is interesting because they don't have any visible trusses. So how are they supporting the roof?
Effectively, what you're looking at is a domed ceiling with truss work. It would probably be above the ceiling part itself, and what you're seeing is a arch segment below it. In addition, you're seeing a series of rods that run from one side to the other. Those gold-plated, I believe they're lion's heads or something. There's a rod that comes back across. Those are actually providing a lateral bracing to the roof system in itself. It'd be the interior or lower chord of the truss, and that would be in tension, holding the walls together. To the side wall, you actually see a lower arch segment that's going down, transferring the loads back into the wall, and again you would have a series of pilasters, buttresses on the exterior of the wall that is supporting that. One of the other things to note here is the shallow dome of the ceiling, and in the next photo you'll be seeing the steepness of the ceiling reflecting the higher arch, which would be carrying or supported by the truss work above the ceiling on the interior of the building.
Okay, so let's take a look at the outside. And here we are on the outside of the Methodist Church.
And here you see between the window segments the pilasters or a buttress type section. It's increasing in thickness as it comes down from the roof line down to the foundation. Again, it's transferring the load of the roof system, the trusses back to those columns, back to the foundation of the church.
And as you were saying, that's a pretty steep, on the inside it didn't look like that, but
No.
on the outside, yeah, very, very high, steep ceilings. Okay, cool. Okay, so Westfield also has some really cool bridges as well. Here we've got this, well, you tell me, what do we got here?
Basically, it's a plate girder bridge, railroad bridge. Your primary carrying members are continuous beam girt bridge with reinforcing cross members between two large steel girders. The loads transferred to the ground through a number of steel structural columns, truss columns, each of them going back down to a concrete foundation on rock. The bridge in itself, I don't know, do we have the span on it? It's probably a quarter mile across.
Yeah.
And it's, you'll have to identify the age or that.
Yeah, I can
of it.
find that out. We'll put it in the text.
Okay.
All right. Okay, and then one last. Okay, and then we got our last bridge here. This is the bridge that Abraham Lincoln rode over on his way to Westfield. So, what can you tell us about this?
This would be a typical railroad stone arch culvert bridge. Basically, you're taking the railroad tracks across one of the local streams, and it's made up of a series of stone blocks built in a arch. The construction would have been done with false work or scaffolding supporting the stones as they're put in place. Once the stones are in place and you backfill the structure, the walls, the vertical loading puts the stones in compression, and it becomes self-supporting back down to the rock stream bed. There would also be a, you can see on the right-hand side in particular, a wing wall coming back out, again supporting the earth backfill for the railroad embankment.
All right, well, Todd, thanks so much for taking us through Westfield, okay?
Very good.
Appreciate it.